would support a column of water to what height? This means if we have a pressure, certain pressure, the gauge of the mercury will be of 76. The height of the mercury will be 256 millimeter Hg. Okay. That is, if the pressure here, this means if this is the height, what's the pressure outside? The pressure here, if this is closed, the pressure here is 256, and that's why this makes the mercury go to 256 millimeter Hg. If we put instead of mercury, we put water, what will be the height? It's the same instrument, but we have water here. What will be the height?
It would be the same pressure, right?
Same pressure outside, yes.
Multiply the height by the density of the mercury and change the units.
Okay. Why did you say that? That's a good answer, but why? How did you find it?
Because P1 equal P2.
Pressure equal to what?
Hg. HGD.
G. All right. This is now, if it's for mercury, Hg, and the G is gravity, is same. And it's exactly equal to HdG for water, which is H2O. All right. So the G will go with the G. What do I have here? You have the height of mercury.
256.
Yes, this is Hg. Okay. What's the pressure? What's the density of mercury?
13.6.
What's the density of water?
1.
1. So what will be H2O? Hello?
348.
3,480 millimeter. See, the mercury will go of a height of 256 millimeter. If you put water, you will measure the pressure, but you will go to 3,480 millimeter, or 348 centimeter. Is this clear? So you can see that's why people are using mercury, because if we use water, we will take, it will be very, very high to measure anything. For 256, we use 3,480 millimeter water. So which one is the answer?
A.
Good. Next, a flask containing neon gas is connected to open-end mercury manometer. What's the manometer?
Pressure meter.
Pressure that
Instrument to measure the pressure. So it is pressure meter, yes. And what's the shape of it?
U shape.
U shape, something like this. Not good in drawing, but this is connected now to a flask, and this is connected to the air. And what's inside it? Inside it is mercury. Right?
Good.
So this here, we have mercury. Okay, next. The open end is exposed to atmosphere where the prevailing pressure, so what's the pressure of the air?
745 torque.
Torque. What's torque?
mmHg.
Hg. Okay. Now, the mercury in this tube was of this level. So this is mercury everywhere. And the mercury in this side is lower. The mercury, the level in the open arm, in this open arm, is lower by 5 centimeters. So the distance from here to here is equal to what?
5 centimeters.
5 centimeters. What's the pressure of the organ?
The pressure of the air minus the height.
It's actually as simple as that. It's 745 minus what?
5.
I think the pressure of the height
No,
or
It's
the
just-
height.
this number.
50.
5.
Yes. Why did you say 50, not 5?
I converted to a millimeter.
Exactly. And that's it. This is the answer. 745 minus 50. Because all of this is measuring the pressure by height. The height of this one is higher than, is upper. Which one is having more pressure? The air or the organ?
The air.
Air.
What? Because this is going lower. So yes, the air, pressure of the air is greater than the pressure of the organ. Clear? And that's why you have to subtract the difference in the height, which is in this case 50 millimeter. And so what's the answer? Is 695. So which one is the answer?
Doctor, do we always convert the height of the centimeter to millimeter?
Well, no, you don't have to, but what's your unit here?
Millimeter.
So what's the unit that you should have?
Millimeter also.
Yes.
If the unit atmosphere, do we convert it to torque?
Of course, if it's atmosphere, you have to change it to millimeter Hg so that we can have the height.
Okay, thank you.
Yes, you have to change it to millimeter. And when you subtract, make sure that you don't subtract centimeter from millimeter. Good. Question 3. How many molecules gas are present in 2.5 liter at 50 degrees C and 650 millimeter Hg? What's the very first thing you'll do?
Convert this to ATM.
Change the pressure to ATM.
How can you change it?
Divide by
by
760.
Go ahead, calculate the pressure. Then what's the next step?
Find the number of moles.
Temperature.
How?
Change the temperature to Kelvin.
That's it. Go ahead and tell me how many moles do we have?
(8.06 times 10 to the power minus 2.
8.06 times 10 to the power
Minus 2.
minus 2 more. Who got the same answer?
Yes, doctor, it's the same.
Me.
Good. Can you change it to molecules?
Multiply by Avogadro's number.
That's the answer.
4.9 times 10 to the power 22.
4.9 what?
8.5 actually.
0.853.
853.
Okay. So it is 4.9 times 10 to the power 22. Excellent. All right. Question number 4. Assume ideal behavior. What's the density of argon, AR, at STP? What's STP?
Standard temperature pressure.
What's the standard temperature and pressure?
0
0
Celsius and
Celsius.
pressure is 1 atm
Zero
in 1
And-
mole.
to 1 atmosphere. Good. All right. We know that PV equal to nRT. Can you change it to density? What's N? And we know that N is equal to what? Mass over
Molar.
Molar mass.
molar mass. I will put here instead of this one, then I will put PV equal to mass over molar mass RT. And then I will say that P times molar mass equal to mass over volume RT, or this is of course density, so density equal to what?
Pressure multiplied by molar mass over RT.
Good. All right. Do you have everything in here? What's P?
1 atm.
1 atmosphere.
Okay. What is T?
273.15.
Okay. Then what will be the molar mass? What's the molar mass of argon?
39.95.
Okay, put it. Give me the answer then. What will be the density?
D.
1.78.
1.78. Who
Yeah.
was the same answer?
I got it.
Yes.
Gram per what?
Liter.
Per liter.
We're dealing, this is in gram, and the volume is in liter, so it's gram per liter, exactly. Very good. So this is the answer. Is this easy? Okay.
Yes.
So let's go. Next. Okay. 0.271 gram sample of unknown vapor. So we don't know what's this gas. Okay. Occupy 294 millimeter at 140 degrees C and 847 millimeter Hg. The empirical formula of the compound is CH2. What's the molecular formula for the compound? Molecular formula for the compound. In order to know the molecular formula, I want to know the molecular mass. And can I calculate the molecular mass of this gas? Providing with this.
Yes.
Use this equation. What's this equation now? Can you use this equation?
Yes.
M is equal to what?
DRT over P.
Over what?
P, the pressure.
E. Good. What's the density? What's D only?
Mass over volume.
Which is what? 0.271 gram divided by what?
294 times 10 to the power minus 3.
Or 0.294 liter. Exactly. So you have the density, you have T, you have P. Calculate what's M. Quickly, go ahead.
28.05.
want more than one person to do it. Somebody got 28.
Yes, me too.
0.05. You too? Who else? Okay. How can I find, if this is the empirical formula, what's the meaning of empirical formula?
The simplest
Small
formula.
one.
Simplest one.
Simplest, which is CH2. What's the mass of the simplest formula?
Approximately 14.
Approximately 14.02, right?
14.02, yes.
This means if I divide 28.05 by 14.02, what am I going to get?
2.
2.
Two.
So what's the formula?
C2H4.
C2H4. Exactly. Is this easy?
Yeah.
Good. Let's go to 5. When active metal, such as magnesium, is immersed in acid solution, hydrogen gas is evolved. Calculate the volume of the gas at 30.1 degrees C and 0.85 atmosphere that can form when 275 milliliter of 0.725 molar HCl solution react with Mg. So what's the first thing I'm going to do? I'm going to calculate moles of what? HCl. How can I calculate the moles of HCl?
Multiply the volume by the molarity.
Exactly.
Yes.
What's the volume?
0.275 liters.
And the molarity is 0.725. Should I keep it milliliter?
No.
No, change it to liter because molarity is mole per liter. So yes, I should multiply 0.725 times 0.275 liter. What's the answer?
0.199.
0.2.
199 mole HCl. How many moles H2?
Divide by 2.
Divided by 2.
Why?
Because 2 mole HCl equal 1 mole hydrogen.
Yes, so this will be 0.099 mole H2. Good. Now we know the number of moles. Can you tell me what's the volume? Yes?
nRT over P.
Don't forget to change the pressure to atmosphere. It's already atmosphere. And change temperature to what?
Kelvin.
2 Kelvin.
Okay, give me the answer. You have the number of moles, you have the temperature, which is 30.1, and you have the pressure, which is 0.85. What's the volume?
Two point nine.
2.899.
2.89.
2.899 liters. 2.8. This is easy. Okay, number 7. 7.5 liter gas contains 0.482 grams of hydrogen H2 gas and 4.98 gram of oxygen O2 gas at 65. What is the partial pressure of oxygen in the flask?
دكتور معليش بس السؤال اللي فوق كيف جبت المول H2؟ كيف جبت 0.0
لأن في واحد
ضربتها في 2؟
قسمت على اثنين.
اها
فال2 مول H2 يعطينا 1 مول 2 مول HCl يعطينا 1 مول H2 عشان كده قسمت على 2. All right, good. Let's go to this problem. Now, first thing we should do, calculate number of moles of oxygen. .98 divided by what?
7.75.
32.
I mean,
Which is 7 point what? Yes, an answer.
0.156.
0.15.
Zero point 1.556. Okay, more. O2. Good. Next. Do I have to do anything with hydrogen?
No.
What's the pressure of O2 only? Is equal to what?
The number of moles of O2
Times
RT
R times T, which is 65 plus 273.15 divided by what?
7.75.
Give me the answer.
0.557.
All right. Can I do the same thing for? Can you find the pressure of H2?
Yes.
What's the first thing you should do?
Calculate the moles.
Number of moles. Calculate the number of moles by dividing the mass of hydrogen, which is 0.482, divided by the mass of H2 molecule. Find it quickly.
.239.
Anybody got the same answer?
Yes.
Yes.
This is the number of moles or the pressure?
Moles.
Moles.
Oh, moles. So the moles is what?
24.
0.24. 24 what?
It's 239 actually.
239. I want 3 numbers. Okay. 239. Okay. Multiply it by R times 65 plus 273 divided by 7.73. You give me an answer.
Zero 0.856.
0.8.
856.
Anybody got the same answer?
Yes.
Yes.
Yes,
Then what's
Dr.
the P total?
Add B of H2 and O2.
Add them together. Good. All right.
Doctor,
Yes.
if he asked about oxygen molecule, do we divide by 32 or 16?
Oxygen molecule 32 right away. You cannot say oxygen molecule. If you say oxygen atom, then it's by 16.
But molecule 32, right?
Exactly. A hydrogen molecule, hydrogen gas is H2. Hydrogen molecule is H2.
Okay, thank you.
Okay. I'll go to 9 and then 10 and then we will go to 8. Last thing. 9. A compound composed of carbon, hydrogen, and chlorine. So it's CHCl. Okay. A fuse, what's the meaning of fusion? Go through the pinhole. All right? Through a pinhole, 0.411 times as fast as neon. Neon is in E. What's the molecular formula for the compound? What should you do to solve this problem?
We use Graham
EO.
rule.
I know that rate of a fusion of gas divided by rate of a fusion of neon equal to what?
The root of
Molar mass.
I want to say this at the start. That's the meaning of what he's saying at the beginning. It fuses through a pinhole 0.411 time as fast as neon. So it's 0.411 compared to this one. This one now is equal to what?
Molar mass of Ne over molar mass of the gas.
Molar mass.
Mass of what?
Neon, the gas.
Neon divided by molar mass of gas. So, what's the molar mass of neon?
20.18.
20.11.
20.18. Okay, so what's the molar mass of gas?
hundred and 19.46.
There was more than one to say it. I don't know. I'm not sure. Somebody said 119 point what?
46.
Who else got the same answer?
Yes, the same.
Me.
I hope so. Good. So, what compound is this one? Which one of these compound is 119.46? Don't forget that this is 12, this is 1, and this is 35.45. Which one will make this amount?
The first one. A.
Exactly, it's A. Why? Because 12 plus 1 plus 35.45 times 3, this is about 105, 106, and this is about 118, 190. That's exactly about 119. All right? If you try anything else of these, you will not get to 190. So this is the guess. CHCl3. Is this clear? Good.
Doctor,
Yes.
how do we get to 109.40?
This one?
Yes.
Did you solve this equation? You have to solve this equation. Do you know how to solve it?
Oh, yes, okay. Yeah, I know. I just.
Okay, good. Next, question 10. 3 on 12 CF2Cl2, which has been widely used in conditioning. That's what you use in the AC, but we don't use it anymore, or they're trying to reduce it. is considered a threat to ozone layer in the atmosphere. Calculate the root mean square. So we want the root mean square speed of 3 on 12 in lower atmosphere where the temperature is minus 65 degrees C. What's this equal to?
Root of 3 RT over molar mass.
Over molar mass. Okay. And this is equal to what? 3 times which R?
0.8.
0.314. Okay. 8.314 is the R because it's joule. All right. What's the temperature?
$208.50.
108.15. I didn't know. Okay, good. What's the molar mass of CF2CO2?
In kilogram, right?
Yes, but what's the molar mass first?
Oh, 120.9.
I don't know. Somebody help me. Is it 120? Use your. Anybody else got the same thing? 120 point what?
0.9.
Yes, me.
Who else?
Yes, I get this.
Yeah, 120.9.
Then calculate your RMS.
207.
I hope this is clear. This is easy.
Yes.
Good. Now, let's solve this problem. Problem 8. The mole fraction of oxygen in air. The mole fraction. What's the meaning of mole fraction? It's X of O2. Don't forget this. What volume dry air at 1 atmosphere and 25 degrees C is required for burning completely 1 liter of octane? 1 liter of octane. The octane is C8H8. The density is 0.7025 gram per milliliter. What's the mass of the octane in this case? If the density is this one and the volume is 1 liter, what's the mass?
Same as density.
No, this is per milliliter, and this is liter. Is this clear? What did they do?
Changed it to
into
liters.
the power 3.
What?
You changed it to liters. Gram per liter.
Because it's gram per milliliter, and this one is liter. Good. Now, you are burning C8H18. C8H18. How do you do combustion reaction?
Plus O2 equals H2O plus CO2.
Is this balanced?
No.
You balance it. 4, 9, and this way, what's the amount of oxygen?
$17.
This is 8. This is 8. Okay. What's the amount for oxygen?
25
Right?
25 over 2.
20?
over 2.
25 over 2. Exactly. So if I want to change it now to normal one, it will be 2C8H18 plus 25 O2 to give me 16 CO2 plus 18 H2O. Clear? Good. The mass here, mass of octane is 702.5. Never deal with mass. Change it to moles. How many moles is this?
Six point 1.15.
6.15
1.5.
115 or 115?
1.5.
Who got the same answer? You divide this by the
Yes.
molar mass of C8H8, which is 8 times 12 plus 18 times 1. Did you do that?
Yes.
Yes.
Good. That's moles C8H18. How many moles oxygen do I need?
76.88.
76?
0.88.
Who got the same answer? You should multiply.
Yeah.
You should multiply this by 25 and divide by 2.
Yes. Same answer.
76.88 mole O2. Can you
Yes.
tell me, if you know this is the mole of O2, can you tell me what's the moles of air? Mole total, MT. What is it equal to? Don't forget, the mole fraction of O2 is equal to what?
Mole of O2 over total mole.
Mole of O2 divided by total moles, T moles. Okay, what's the mole fraction equal to?
0.2.
What's the N total then?
366.96.
My good one. What are you going to do? You should divide this number by 0.2095.
So 366.96.
What?
366.97.
Oh, 1 second.
Exactly. Can you find the volume? It's nRT over P. The N we have it here in total. R is 0.0821. Temperature is 25. And pressure is 1. Calculate the volume.
equal 8,982.73.
8,000. What?
8,982.
8. It's actually less than that. It should be 7. 7. This means this is the correct answer. Is this clear?
Doctor,
Yes. Before
is this difference in answer? Okay. Is this difference in answer will affect the final answer?
no, you have always you have to choose the closest answer because maybe you use less significant figures or more significant figures.
Okay.
But you should choose the closest answer. Okay, the attendance is open now. Go ahead and make attendance.
Doctor, where did we get the total moles from? How did we get them?
Just a second. Let's see. Okay, now let me do this one more time. I will erase this and I will start. Okay. One more time. Okay. Do you know how we get the moles of oxygen?
I'm sorry,
What?
Doctor, what?
Do you know how we get the moles of oxygen?
We made the equation, then we used the
Exact correlation. We calculated the moles of octane and multiply by 25 and divide by 2, multiply by 25, divide by 2, and you got the moles of oxygen. As simple as that. All right?
all right.
Then the mole fraction, it says here, the mole fraction is 0.2095. So this mole fraction is 0.2095 is equal to what? Moles of oxygen, which is given to us here, 76.88, divided by what? In total.
In total, yes. Yeah, I understand now, Doctor. Thank you.
Okay, then you can calculate in total, which is equal to 76.88 divided by 0.2095, and this will be the answer.
Oh, thank you, Doctor.
All right. Okay, let me stop recording here.